Morning, ladies and germs. I woke up this morning to check my YouTube feed, and I noticed a video from Steve Robb with my name, my username, plastered all over the thumbnail. And yeah, the guy I met, I was a little scared. And yeah, I'm drinking water today, so this will be somewhat of a serious video. I try to make it fun. Because he's been having problems with this electric eye that he's been having problems with. He wants an LED or a series of LEDs to turn on either at dawn or at dusk, or turn off, vice versa. Regardless, we'll go over both ways of doing such a thing. And he showed a breadboard with, and this is the one part he's missing. You need an op amp, my friend, and we're going to go over a couple other design techniques of how to stabilize the signal using what's called a Schmitt trigger. That's S-C-H-M-I-T-T, Schmitt. I think I spelled that right. And using an op amp as a comparator. We're also going to use a technique called, a really fun word, I like it a lot, it's called hysteresis. What's hysteresis? Hysteresis is it's two different voltages as an input. There's two different voltage inputs. One is set at a different level, one is set at another level, and it creates a gap. Now that gap is what's called hysteresis. It's kind of like setting like a trip point. Okay, so one will be on, and then when it hits to another level, it goes off. And when it gets to another point, it'll go past that, and then the other set point, it'll turn on. So it's got two set points. One's go on, one's to go off, and you can switch those. We'll go over how to do that. But that's hysteresis. A Schmitt trigger, all that does is that it cleans up the signal, because when you're using a part like a CDS cell, that's cadmium sulfide, when you get really close to the trigger point, or the high side or the low side of the hysteresis point, because you're dealing with light and sunlight and clouds and stuff like that, you'll get noise, okay? And the Schmitt trigger it'll buffer it out, it'll clean it up, okay? So that's something else we want to do. We're going to do that. I got a bunch of resistors here. I got a 470 ohm, 1K, 4.7K ohm. I got a 10K. I got a couple potentiometers. I got some really nice vintage HP LEDs. These things are older than me, and the circuit that we're going to be using is older than this. So we're really going back to basics with this one. This will be fun. We'll see. We'll do it up on a breadboard. We'll actually show you in real life that it works. And I have a power supply here that we can use to simulate a battery. I don't know if he needs a charging circuit for his battery. He didn't mention that. I would like to note that he should be using a deep cycle battery. We call those marine batteries. Those are the kind of batteries that you'd find on a boat. That's the kind of battery you would want to use. You could use a lead acid battery, like a car battery. You could use those as your battery bank. But they're not as efficient when using that kind of drain. See, car batteries are meant to put out a lot of current real fast and then charge back up. That's it. They're used for a split second to hit the starter for the starting motor. And that's it. That's all it's used for. The alternator takes care of the rest because the engine is running. and that's how your things stay on. And that's why if you turn your car radio on and you leave it overnight, your battery's going to be dead in the morning. However, if you used a deep cycle battery, that radio would probably stay on for days. That's the difference between a lead acid battery and a deep cycle battery. Okay? There are two different types of batteries, two different types of they're just two different types, and you want to use the right kind of battery. So that's a point for failure if you didn't know that. So hopefully you learned something already. Oh boy, what else can we do? I'll probably be throwing Mr. Mook out because he's probably going to get in my way soon. And yeah, I'm drinking water, folks. Boy, it's early. It's around 6:30 in the morning. Yeah, he threw me under the truck. Thanks, Steve. Appreciate it. Yeah, at least I get to do something fun today. This is the chip we're using. The op amp we're going to use. It's the LM358-N, as in Nancy. That's the 8-pin dip version. As you can see here, suitable for battery operation. So this is right on our alley of where we want to go. This will certainly work off of our 13.8 volt voltage range for the car battery or deep cycle battery, which I hope he's using. It wouldn't matter. I mean, yeah, it matters. It totally matters. But they are expensive. That's why they're expensive, because those are the ones you want to use for this type of application. So that'll be part one. Stay tuned for part two. Good night, ladies and germs.